Okay, so on this sheet, phones away, paying attention. Here we go. Number 1 and 2, let's just do a couple of these together on the board. Let's do some tricky ones. What is the oxidation number of Cl2?
0.
Everyone?
0.
Good. Maybe. Come on. What is the oxidation number of this, Raj?
-2.
Try again.
Negative?
Why would it be -2?
Is it just 0?
Cl minus.
So would it just be -1?
-1. What are the oxidation numbers in this compound, Jacob?
-2.
For what?
+1 for the first one. And then Cl is +1 and -2 for the last one.
So -2 for the oxygen is correct. Yeah. Then how many oxygens have you got?
-6.
-6 in total, and so therefore the chlorine, which is the one you do last, +5. Okay. Let's go over to this one. Craig? KClO2. What do I do first? Okay, and what charge will you give it?
+1.
Good. Then?
There's 3 oxygens.
So?
Which is -3.
Nope, -2 each.
Oh,
I think there's 2 oxygens. So
yeah, sorry, I think there's 1. Where am I? Just 2. Yeah.
KClO2. So there's 2 oxygens, -2 each, so that's a charge of -4 then in total.
You need Cl needs to be +3.
So Cl needs to be +3. Good. Good, everybody? All right. So let's skip down to the questions that you did. The first one here, I've done I've done the first few steps for you so that you could have just to concentrate on the last couple steps. So you can see that the AS is losing 2 electrons and the maybe losing 2 electrons, good. And the I'm not sure why that circle's there, but it's not going away. Does it say 2 electrons?
Yeah.
Good. And the gain is 6 electrons on the I. So what do I need to do? Look for subscripts, of which there aren't any. So then I just need to balance my loss and gain. So I need to multiply this by 3 in order to have 6 electrons lost and 6 electrons gained be balanced. Correct? And then what do I do with that 3? I need to bring that times 3 up to the AS's, and I need 3 AS's on this side as well. I need 1 I and 1 I, and that should be balanced in everything. Is it balanced by oxygens? Yeah. 1, 2, 3 times 3 is 9, plus 3 is 12, and over here I have 4 times 3 is 12. Is it balanced in the charges? Because it should be.
Yeah.
3 times -3 is -9, plus a -1 is -10 on the left-hand side. On this, it's also 3 times -3 plus a -1, so it's also -10. So this is why I don't need acidic conditions. Okay? Question 4. First thing you would have done is added oxidation numbers to everything. +2, -2, +1, -3, 0, +1, -2, and 0. These, of course, are just the base numbers. And you'll have noted that the copper changed from 2 to 0, and that the nitrogen changed from 3, oopsies, went too far, to 0. So the copper going from 2 to 0, the number is decreasing or being reduced. Therefore, it must be reduction, half reaction, and gain 2 electrons. And the nitrogen must have been oxidation, oopsies, oxidation, and therefore lost 3 electrons. Everybody get that? Mm-hmm. Did you get that? Good. And so now I have to look at subscripts, of which there aren't any. Hooray. And then I look at the number lost and gained. So I need to multiply this by 3, multiply this by 2 in order to get 6 electrons gained, in order to get 6 electrons lost. And what do I do with those numbers?
Carry them up the bridge.
Carry them up the bridge. So I need 3 coppers. 3 coppers. 2 nitrogens. 2 nitrogens are already 2 nitrogens there, so I don't need a big 2. And now I balance everything else by site because it's not acidic condition, so they don't need to worry about the H plus thing. In fact, to balance the charges, are the charges balanced? Yes, neutral, 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 neutral. So now I need to balance everything else. So 3 oxygens on the left, I need 3 oxygens on the right, which also made my 6 hydrogens work out. Hands up if you succeeded in getting question 4 completely correct. Good, well done. Was there an issue on any of the others? Do you want me to do them all?
Yeah.
Do them all, okay. All right, so going down then the page. So this should be -2. What's the station on Mn on this one? +7, right? Come on. Can somebody just check my station numbers because I did them quickly? Okay, gained 5 and lost 2. Everybody there? Yeah. So, any subscripts to worry about? Nope. And so now I need to, can you stop talking while I'm talking? And so now I need to balance them out by multiplying this by 2 to get 10 electrons gained, multiply this by 5 to get 10 electrons gained, and I bring the timesing up the bridge. So 2 MNs, 2 MNs. 5 SEs, 5 SEs. This is in acidic conditions. Can you see that without the question saying that in the paragraph above? How do I know that, Andy? How do I know it's acidic condition?
Because there's H plus and H2.
Right, because there's H plus. So I'm going to check my charges. 2 negatives and a positive, and over here 2 positives. Those don't equal. So I need, if this side totals a +2, +4, pardon me, +4, 2 times +2. I need the left to total +4. Of which I have 2 negatives here, so I need this to be a 6. Change color on that. I need the hydrogens to be a 6, so that this side totals +4, and this side totals +4 in its charges. Well, I'm not done yet, right? Is everybody okay with those 6 H pluses? I'm feeling a little bit like I've got some, Daria?
I'm just wondering, for this one, I forgot to know that it was in acidified conditions, but it just worked to balance it. Will that not always work to just
Not always.
balance it out?
The first thing you should do is balance charges.
Okay.
So if you get in that habit, then it doesn't matter if you read it wrong or didn't notice the beginning. If your charges aren't balanced, you must need to add some H pluses.
Okay.
Or actually, you could add OH minuses, but you in this curriculum would never be faced with an example of that. Okay? But understand that I could have basic conditions and add OH minuses to balance my charges as well. At any rate, and you'll see a question here or there about that, but I have not asked you those for efficient because we need to, we're 2 weeks behind, so we've got to keep on task. But yeah, so after you finish bringing the numbers up, check if your charges are balanced. And if they're not, you got to play with your H pluses. Okay? And because sometimes they might not have put water there, so then you wouldn't have caught that.
Yeah.
And then I need some waters. I need 3 of them. in order to make the hydrogens, that is supposed to be a 3, in order to make the hydrogens happy. Do I need 8?
Because
Yeah.
you have
Oh, I've got
5 times
10
2.
here.
Yeah.
Sorry, pardon me. Yep. Oh, I can't undo. So 10 hydrogens there and 6 hydrogens there make how many hydrogens? 16. So therefore 8 waters to have my 16 hydrogens. And do the oxygens work out? 8, 8, good. That's where I would have caught my mistake. The oxygens wouldn't have balanced. And I've gone, oh, something went wrong with my hydrogens. Oh, there are hydrogens over there too. Okay. All right, so this one, 0, -2, -2, -4, +4. This is +1, -2, -8, +7. This will still be +7 and -2, and this will be +2, and this is +1 and -2. So this PB went from +4 to +2.
On the PB SO4, isn't the PB +6 because SO4 has a total charge of 2 minus?
No. Wait.
The S is positive 6.
Okay, hold on. Let me just do it a bit bigger. PbSO4, I'm breaking this up into a 2 minus and a 2 plus. So this is what you want to do? So this becomes a 2 plus, which is what I have.
Yeah.
This is, I didn't really, and then after that I didn't really pay attention, to be honest. I just copied what I did here. -2, 2 times 4 is -8. And then I need a +6. That's correct. So I must have went wrong here. +6, +6. Okay. All right. So your PBs have changed from +4 to +2. How did it do that? Gain 2 electrons. And this PB went from 0 to +2, and so therefore it lost 2 electrons. This is not disproportionation. Okay? This is the opposite of that, I suppose, or something like that. So disproportionation is where one element becomes 2 different things as opposed to 2 things becoming the same compound. Okay? So well done for recognizing that it, oh, we've seen this before. That's good. That's a good thing to have recognized. But actually, on reflection, we have 2 things becoming 1, as opposed to if I wrote this exact opposite way, this side of the equation on this side, and this side of the equation on this side, then that would be disproportionation. Okay, so 2 and 2, so therefore nothing to multiply. So nothing to bring up, so it's like a ×1 essentially. Up here, 1, times 1, up here, 1. But then I'm also bringing that 1 up here and that 1 up here, so in total I have 2 PBs on this side. So you can think of it that way, or you can simply think of, once I've put the PBs on this side, I have 2 PBs, so I need 2 PBs over there as well. Okay? However you fancy thinking about it. And then I'm going to look at my charges. Neutral, 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 neutral. So that's good. And then I'm going to balance the rest by like science 10 method. And I see that I've got 2 hydrogens on the left and 2 hydrogens on the right. So that's good. And I've got 4, 5, 6. That's not good. Oh, I need 2 of these and I need 2 of these. 2 SO4s, 2 SO4s, and 4 hydrogens, 4 hydrogens. Now my oxygens should work. Yes, they do. Good. So 1, 1, 2, 2, 2. Happy? Yeah. Okay. Any questions on those? Do you feel like you can do that with success now? Good. Do you remember how I said at first it's like a gong show, and then after you've got about 20 under your belt, you're going to be okay, right? You've done about 20 now. You're going to be okay, right? So that's the nature of that piece. Okay, so I've also got on this board some oxidation numbers. This is in your textbook. At the end of chapter 12 questions, on page 474. We're just gonna go and do these ones here. This is off of question 3. It's not A, B, C, D. It's A, G, F, something or other. But I picked these 4 because they're a bit harder. So KCN, how are we going to answer the oxidation numbers on those ones? What are we gonna do first? Lindsay. Now you did you back there because yeah, I might call on you. Lindsay.
Sorry, I was looking for this. What did you ask?
These questions are in your textbook on page 474. Not in that package. Pardon? Okay, so the oxidation number on these. Now what? N is probably minus 3, you think?
Isn't CN
Isn't CN what?
like an overall charge of -1?
CN has an overall charge of -1, that is true. So C is plus 2.
Yeah.
Think so?
Yeah.
Couldn't maybe C not be 0?
Couldn't C be 0 and N be -1? Nah?
Let's do, yes.
Couldn't N be okay, what are we gonna do first? The one that has more electronegativity, right? So that is indeed nitrogen that you would do first. And what charge would you give it? Well, you'd give it the same charge that you would give it if it was an ion. So that's -3 as you defaulted to. And then that leaves carbon to be +2. And that's okay because actually by now you've seen carbon be a whole variety of ones. So you're okay with that being whatever it ends up being. So this is your answer.
How do you tell the higher electronegativity again? Do you want the number to be?
How do you tell the number? They're on your periodic table.
But how do you know like which means it's higher? Because wasn't there like there's like negative electronegativity and then
No,
no?
4 is the highest and 0.7 is the lowest on francium, and so therefore they'll have the lower electronegativity.
So you ever had 2 elements with the same and you have to
Yes, but not in that kind of a case.
Not in that kind of
Okay, ASO3, oh no, down here. What do I do first down here? What do you think, Jillian? Hydrogen first? Okay. The overall charge is +1, so then that makes nitrogen, the overall charge is +1, so that makes nitrogen -3 in order to equal out to that +1. So you've broken it up into the ions. You've used that toolkit. Good. And then what is the toolkit you're going to use for the C2O4 then? What's the overall charge there? -2. How do you know that? Because of that 2. Reverse the crisscrosses. Right, so that 2 must be that -2. Okay? So, if that's overall, oh, it's not happy with me right now. Don't touch the board. If that's overall this, then what? C2O4 becomes, oxygen becomes -2, right? Times 4 is -8, +6, +3. So we've got -3, +1, +3, and -2 for the elements nitrogen, hydrogen, carbon,
Do
oxygen.
you mean -3 or -2 for the first one? So we go 2 with some
Oh, 3. This board is not happy with me today. Can you see it's not up here? Which means if I touch it, it's all going to disappear. So I'm just kind of like, fingers crossed. Okay, Rachel.
How come how do you know if the charge of the of the second one is -2, the overall charge is -2 and not +2?
Because when I was looking at this ion, oh, it is +2. No, it's not, it's -2. It's -2. Because when I'm looking at this I on here from the original, which I would love to undo, but I can't. When I'm looking at the original I on here,
Yeah.
okay, you should be able to see that this is made up of an NH4 positive
Oh, okay, so then the other one.
and a C2O4 negative,
Yeah.
of which when I put these two things together in Science 10, this would be a very tricky question in Science 10,
Mhm.
that this, I would need two of these to balance out this -2 charge, so therefore
Okay.
two of these, and that becomes my compound then, right?
Okay.
Yeah. So it's working that backwards. Okay, let's do D. Let's do this one. XeO3F minus. What would you do first? Fluorine first. That's number one rule. Fluorine first when it's given a charge of -1. Why is it first? Because its electronegativity is the highest, so it gets first grabs. So -1. Then what comes next?
Isn't the oxygen not gonna be
The oxygen is going to be 2- as well. Or, I mean, the oxygen ends up being 2-, but if it was only O and F, it might not. F would take priority. So that's -2. I've got 3 of them, so leaving Xe to be +6, because +6, -6, and -1 have to equal -1 from that charge. Those are like your hardest examples that you would get. Okay, so if you can do those, great. If you can't do those yet, you just need a bit of practice over the harder examples. Okay? Can everybody turn to page 474? And I would like you to look at question 5. Okay, so everybody there? Or one between the two of you is fine? Determine which of the following balanced chemical equations represent redox reactions. For each redox reaction, identify the oxidizing agent and the reducing agent. Okay, so we're not going to do the identifying oxidizing and reducing agents, but I do want, I mean, you should be able to do that, but it's going to take the time to do that. You should be able to identify in these now. So in Science 10, you learned double replacement, single replacement, combustion. Now you should know redox. Do I just let you go now?
Yeah.
Okay. So of these, you would be able to see if the oxidation number changes, it is a redox reaction. Okay? That's the answer.
On any of them?
On any of them. If the oxidation number changes, it is a redox reaction. Yep. If it starts with an ion and ends with an ion, it'll be a single replacement or double replacement, no change.
But like, as any school,
Hey.
Hi, hold on. I'm trying to shut this recorder off. If maybe,
5 years together, though, I guess.
you know what? I need to get a new laptop.
There's no judgment.